Hi, good afternoon chaps. Today we're doing something completely different. We're working with the TRU SDX for a change. Now what we're doing today is, this is a low band version, and I decided I'd like to try the other chip, the FT blah blah blah, whatever it is. I've got it lying around somewhere, but goodness knows I can't remember. Anyway, what I've done is I've removed the board. And initially what I did is I put one in. Now before I did anything, obviously I noted the efficiency, I noted the power output using the 3BC170s, and well, I hope they are BC170s. At the moment my brain's not working too well, guys. I'm sure they are BC170s. Let me just double check, and I'll restart this video if it's wrong. Let's start again. Yeah, BC170s, I was right enough. Okay, so I removed them and decided to put in one of the surface mount FETs that go in the classic band and the high band models, just to see what the effect was. Well, what happened then was the efficiency went down a bit, not much, but it did go down, and the power output actually dropped a little bit as well on all bands. So I thought, okay, so I decided then to double it like I have done on my classic band version here. Put two in. As you can, I don't know whether you can see properly there. They're sitting on top of one another, and they're on the board that way. So I did that, and what I did was afterwards I did a check. Now the power has come up. It's come up round about between half a watt and a watt, between dependent on what band, of course, and the efficiency is in the high 80s%. So that's a notable improvement. Now these are quite robust transistors, FETs I should say, and they're less problematical with high SWR, etc. So I just thought, well, I think I'd like to do that if it works, and it's in. Let me just put it back together. Put the back on it so there's no shorts. So we'll now connect up the power meter, and the supply we're using is 3 lithium ion batteries for supply. Now I don't know whether you'll see that, there's a lot of light. I might actually try and just sit it up a little bit, see if that helps with that little wax stick underneath it. Sorry about the mess in here, it's just a bit untidy, but I'll give you the readings, and also the readings off the screen. So there we go, that's us. So let's go back to 80 meters. Okay, we're on CW, and we've got just over 5 watts, and on the screen here it says 6.98. I think I'd rather go by this, and efficiency is 79%. And on 60 meters we've got slightly under 4 watts, and we've got 87%, 88%. 40 meters we have slightly under 4 watts and 86% to 88%. And on 30 meters we've got nearly 6 watts there and 88%. And on 20 meters we've got 5 watts and 87%. So except for the 80 meter band, it's a bit low. It's still not bad, it's still acceptable, 79%, and 5 watts. We've got definitely an increase in power. We were only getting roughly about 3 to 3.5 watts out of this one beforehand, so the power has definitely come up. So that's what we've got with this. Now on the other one, that is the classic band model, using both of the FTD type FETs. Hold on, I'll tell you exactly the right number. I know it sounds a little bit off. FTD86256 is the FET that goes in the classic and in the high band versions. So we'll connect this one up, and I'll show you what the power readings we get off that and the efficiency. Hold on, I have to run that on a different battery, because what we've done is we've done away with the 3.5, sorry, the little jack, the jack burst on this one, and I've just hardwired it. I've had this one for quite a while, I have to say. So, and I've got Anderson power pole connectors on this one, and we're running it off a 12 volt battery. So let's go. I'll change to CW. This one also has had the modification to the display to make it brighter. So on 80 meters, 6.5 watts efficiency. Oh, wait a minute, hold on, we need to change the menu. This one actually works quite well, I have to say. Efficiency, there we go. Efficiency 82% and 7 watts. And I've had no problems with this, even with accidentally no aerial connected to it, no load. 40, nearly 7 watts at 79%, heading towards 80, jumping to 80 occasionally. 20 meters, 7 watts again, 74%. The display says 5.95 watts. 15 meters, we've got 6 and a bit watts, 6 and a quarter. The display says 5.37 and 73% efficiency. And on 10 meters, we've got 70% efficiency and again 7 watts. It says on the display 5.75. So draw your own conclusions from that. I haven't had any issues with this. I haven't had any problems with the FETs going. I haven't had we've checked the efficiency with the current, etc., and done the proper calculations, and in actual fact it is showing up exactly how it should be. I think that's quite reasonable efficiency for 10 meters. Anyway, I do. So I just thought I'd show you that, again, this is done the same way as that one with the two of the new FETs, the surface mount FETs, paralleled up under the board. With one in this, I couldn't get the efficiency anywhere near what it is. I was struggling to get any more than about 65% efficiency, but with the two in it, the efficiency came up. The current consumption, in actual fact, dropped slightly, believe it or not, with two in it. And this is how we double checked it. But we've checked all the second harmonics. We've done all the spacing on the coil, etc., etc. This one, I bought this one second hand, and I have to say, this has an older one. It could be doing with the SWR bridge windings redone to the later type, but it's all in with kind of glue. And I'm loath to have problems with the board, so I've decided just to leave it the way it is. It'll do. It works okay. So I just thought I'd let you know, guys, what we've done with this. These two TRU SDXs, and I can say, I did do another modification incidentally, just while I'm here. This is an old Midland microphone from a CB, and with a 3.5mm jack plug for press to talk and mic. But what I have done is I found a little preamp that uses the electric mic, and I unsoldered the electric mic and put it in where it should live, wires up to the wee board, and connected it up. There's a 3 volt battery there, CR2025 in there, and the connections on the push to talk switch. When you close it, it powers up the preamp. What that does is it gives it more drive to the radio. You can turn down the TX drive to 1, and then you can actually more or less turn the noise gate off, and the audio quality is very good and it's nice and punchy. The output from it, instead of having it just going through like a 0.1 microfarad to isolate the supply to the electric mic, I actually used a 10 nanofarad, and that removes a bit of the bass. It's too bassy, so that makes it sound much more punchy, and you definitely get more. I had a contact actually yesterday into Germany, and I could hardly hear the other side. But the guy did say, he says, you've got a good audio, and he says you're 5 and 7 to me, and he was really poor. I could hardly hear him. It was fading in and out. So there we go. Anyway, I just thought I'd let you see that all what I've been doing with the TRU SDXs, and hopefully catch up with some videos. I've not been doing that many videos. Too many things going on here at the moment. So thanks very much for watching. Take care, everybody, and catch up very, very soon.